question here says, find the value of Kp for the reaction below if Kc is 3.7 times 10 to the minus 7 at 298 K. And this is actually the same reaction that was used in question 1. But if we look here, Kp is for the units of pressure, which is in atmospheres. Kc is for units of concentration, which is in molar or moles per liter. And you can relate these two things. Specifically, Kp equals Kc to the times RT all raised to the delta N. All right, so Kp equals Kc times RT raised to the power of delta N. And delta N is moles of gas from the products minus moles of gas from the reactants. So we're looking at the change in the moles of gas. Note that if something's not a gas, it wouldn't be part of the change of moles of gas. R is the ideal gas law constant, which is 0.08206. That's liter atmospheres per mole K. And if you remember back to gas law, the temperature for gas law has to be in Kelvin. Sorry, I keep going off the screen here. So this is R, and the temperature is already in Kelvin. So now we can find delta N. Delta N equals the moles of gas of the products are going to be 2 minus the moles of gas of the reactants. Notice that everything on the reactant side is a gas. So we have 2 plus 1, which is 3. So in this case, delta N is equal to -1. So Kp equals Kc, 3.70 times 10 to the minus 7 times RT, 0.08206 liter atmospheres per mole K, it's up here, times the temperature in Kelvin, which is 298 K, all to the delta N, which is going to be -1. When you do the math, you find that Kp is equal to 1.51 times 10 to the minus 8th. So this is the value of Kp. Note that if the moles of gas is the same on both sides, then Kp and Kc will be equal, because if delta N is 0, you raise something to the 0, it'll become 1, and Kp equals Kc, and we'll talk about that a bit more in the next question.